My name is Ben Ward. I'm a senior lecturer in inorganic chemistry, and my research is on making polymers. One of the challenges with traditional plastics is that they can't be recycled very easily.
My name is Taylor Young, and I'm a third-year PhD student in the Ward Group in the School of Chemistry at Cardiff University. So my research focuses on sustainable plastics, specifically polyesters, and we look to synthesize materials that have the same material properties as current legacy plastics, but are more degradable, and we can break them down into their starting materials to reform virgin polymer that has the same material properties as the starting polymer.
What we've tried to do is to use the ring opening copolymerisation, and that uses two different monomers, one called an anhydride and one called an epoxide. And this gives you potentially thousands of different chemical identities of polymer, and all of which are esters and can in principle be recycled. Before we purchased the Reactor-Ready, we were limited to about 0.5 gram. And we have a small vial, and this is what we used to use to do our reactions in. And this would go into an aluminium heating block, and it is still what we use for catalyst development, and it's very useful.
So we use the Reactor-Ready for scale-up polymerisations. So we test them on a small 1 mil scale, and then we put them into the reactor that we see behind us and scale everything up. The idea is that we can get large amounts of material for this that we can put into materials testing. So the way in which we do that is to charge the reactor with monomer, solvent, and our catalyst, and then we get to set the stirring and the temperature, and then we can essentially precipitate the polymer at the end and have about 1 kilo of polymer to work with for material testing, which is really important for the engineering purposes that we need to test. The Reactor-Ready has enabled me to do that, whereas before I could never have enough material, so it's really progressed my research to a whole different level.
In order to scale up the reaction, we needed to be able to have good stirring and also good temperature control. And so when we're using our small vials, using an aluminium heating block, the aluminium block surrounds the outside of the vial and provides that adequate heating that we need. We needed to have a system that would replicate that on a much larger scale. And so the oil flowing around the outside through the jacket of the reactor would allow us to get that temperature control.
And the way in which we do this is using the internal temperature probe. So this allows us to have confidence that the polymerization is at the temperature that we set it at.
What that means is if the reaction starts to run away, then we detect the temperature increase immediately, and our heat circulator pump can start to cool the reaction to take away that exotherm and make it safe.
So at first glance, the reactor is quite daunting to work with, but it's actually very easy to use and easy to maneuver, and also allows scale up far more accessible from the 1 mil scale that we used to. We're able to set the temperature control really easily, and it gives us confidence to leave it for long periods of time.
For an equipment specialist, we needed to talk to people in terms of the process that we wanted to achieve. We had a process that was refined and worked very well at a very small scale, but we didn't really know what equipment was available and how it could actually allow us to scale up our reaction. So we had lots of conversations with Sarah, and she demonstrated the equipment. And we actually looked at it with the whole research group to try to work out if it would meet the needs that we had, which it did.
So my favourite feature of the Reactor-Ready is the bottom outlet valve. This allows for workups of our polymerisations to be very efficient and very easy. Because we're working with large volumes of solvent, we can easily precipitate our polymer out at the end. I also really enjoy the condenser that we can attach. This helps us with volatile monomers and is essentially a game changer.